today we discuss some questions based on molecular orbital theory and molecular orbital configuration. Okay, so first see the direct question. So that is among so already we said these questions, the questions based on molecular orbital theory. So mainly comparison takes place. That's why we are giving the question. So among KO2 means it's a potassium superoxide and aluminate and barium peroxide. Unpaired electrons present in dash. Okay, means more than one good couch. Okay, which of the among the three chemical species which are having unpaired electrons in the totally molecular form? So you need to write the two different their configuration. First we see about KO2. So it is the KO2. Actually KO2 is an ionic compound. It is having O2 plus and O2 minus. Okay, so you know already in O2 minus we have there is unpaired electrons are present. If you see the O2 minus configuration, there is how many electrons are present? Is totally what? How many electrons totally? Eight plus 8 by gaining 1 electron has become 17 electrons. We know the 17 electron configuration is 1 is sigma star 1 is more than 14 means first sigma 2px, so pi 2py, pi 2pz. Here one important thing I want to tell you that I used a sigma for x and I used a y and z for pi orbitals, pi molecular orbitals. In some books x and y are used for pi bonds, pi molecular orbitals. Z is used for sigma. So whatever it is, I used x a separate group, y z a separate group. In some books it will be given that xy are one group and xy are used for pi molecular orbitals. Z is used for sigma. So nothing, there is no other change. Pi star 2px, pi star 2py, sigma star 2px. Okay. Now fill that electrons, you will get 2 to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 15, 16, then it is 17. So it has one unpaired electron in pi star 2pz. Okay, means so one is KO2. KO2 has unpaired electron. That is one answer. So we need to check others also. Okay, let's write down. So we need to check others also because it may be more than one answer. So one answer is what is the answer you got? That is okay, KO2 has unpaired electron. Then we check the next one. So Al2 minus. So Al2 minus means here Al is generally plus 3 form. Al plus 3 form. Al plus 3. This minus 2 means the overall AlO2 is having totally minus. Totally minus means an oxygen it will get O2 minus 4. Okay. So O2 will get minus 4. So O2 will get minus 4 means so how many electrons? The 8 plus 8 plus 4, the 20 electrons. Okay. So on plus 4 plus 3 and minus 4, the total we will get minus 1 charge. Okay. So again fill that electrons more than 14 కాబట్టి 20 fill up చేయండి. So up to here already written 17. Okay. 16, 17, 18. So 2 to 4, 5, 6, 7, 8, 9, 14, 15, 16, 17, 18. Fifteen, 16, 17, 18, 19, 20. There is no unpaired electrons are present. Okay, there is no unpaired electrons. So as it is ionic compound, we are so barium plus 2, O2 minus. In barium plus 2, there are no unpaired electrons. Al plus 3, no unpaired electrons. K plus, no unpaired electrons. You can write the normal configuration for them. Okay. So O2 minus. So how many electrons are there in O2 minus? 8 plus 8 plus 1. So here O2 minus 2. So barium plus 2, it's O2 minus 2 means again you will get 8 plus 8, 16, 17, 18 electrons. Okay, it's called barium peroxide. So 18 electron fill up chain. So 18 means the same configuration. Just remove 2 electrons. Now also there is no unpaired electrons. 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. Right, there is no unpaired electrons. Means only KO2 only has unpaired electron in it. Okay, that is only one electron. That is also only one electron. Okay, like this we need to take the configurations. Let's see one more question. Means to do all questions you must perfect in the electronic configuration, that is MO configuration. Let's see one more question. So it is also comparison that which of the following pairs which of the following has same bond order? Pairs means in every option there is a pairs are given. So in the first option there is N2 and O2 plus 7. So we need to check the all options. Okay, here which are having same bond order. So how to calculate the bond order? So we know the bond order formula, that is so after writing that all molecular orbital configuration, what is the formula for bond order? So that is bonding molecular electrons minus anti-bonding molecular electrons by 2. So here it is not asked that what is the bond order. Just the question is which are having same bond order. So we know that it depends on number of electrons. If number of electrons are equal, configuration will be equal. then we will get the same molecular orbital configuration bond order. Means simply we need to check the number of electrons. If number of electrons are equal, the bond order may be equal. Okay. So now check the number of electrons in different molecules. So first check the first option in A. So what is the number of electrons in N2? That is 14. So what is the O2 plus 8 plus 8? 15. This one 14. Is it right? I think it's 15. So O2 means 8 plus 8, 16 electrons. Plus by getting positive charge and by losing 1 electron. So it's not possible. Next see, check and second option. N2 same 14 electrons. O2 minus 16, 17 electrons, not possible. Next take N2 minus. N2 minus means how much? 7 plus 7, 14. By adding 1 electron, 15 electrons. Next O2. O2 will be 16 electrons. I think O2 should be plus. Okay, here some are having 14 electrons. Okay, same electron, same border, but the formula will be changed for 14 electrons and above 14 electrons. Means we need to check the configurations also, but more than 15 electrons, both are more than 15 electrons, so it's not possible. Next see O2 plus. మనం అన్ని ఆప్షన్ చెక్ చేయాల్సిన అవసరం లేదు. సో ఇప్పుడు ఇక్కడ బోత్ ఆర్ మోర్ దాన్ 14 ఉంటే ఈక్వల్గా లేవు, సో దే డు నాట్ గెట్ సేమ్ బాండ్ ఆర్డర్. హియర్ O2 plus 2. O2 plus 2 means how many? It's a 14 electrons. Okay, 16 plus 2 got means by losing 2 electrons. N2 is a 14 electrons. So both are having same number of electrons, exactly same number of electrons. It's compulsory they are having a same bond order. So it is one option. Next, so it is not at all possible. Okay, because more than 14 electrons ఉన్నాయి, different electrons ఉన్నాయి. But here maybe it is possible that 14, 15, 14, 17. So they are not having equal number of electrons లేవు. సో ఈక్వల్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ లేవు, కానీ ఒకటి 14 దగ్గర ఉంది, ఒకటి 15 ఉంది. దెర్ ఈజ్ ఎ కాన్ఫిగరేషన్ డిఫరెన్స్ ఈజ్ దేర్. కాబట్టి మనం 14, 15, 17కి వీ నీడ్ టు చెక్ ద కాన్ఫిగరేషన్. ఓకే, ఫస్ట్ we read the configuration for 14 electrons. Okay, first I am writing for 14 electron configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2py is equal to pi 2pz. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12, 13, 14, and the sigma 2px2, it is completed. Okay, just for getting option we written 3, 4, 5, 6, 7 to 14. So what is the bond order? Bonding electrons, I think already we will get bond order 3. Already we know that in N2 molecule 3 bonds are present, but we do 2, 2, 4, 5, 6, 7, 8, 9, 10. So bond order 3. Then what about for 15 electrons? Okay, when here bond order 3. Okay, what about 15 electrons? So 15 electrons means the configuration is somewhat different at this position. Okay, now we read that 15 electron configuration. So here see, just for purpose, sigma 1 is to same, sigma star this is same, this is same. So here only it is different. Sigma 2px2 and pi 2py2, pi 2pz2. Here only 40 electrons. We need to get 15 electrons. 15 electrons కాబట్టి ఇంకోటి కూడా ఎంటర్ అవుతుంది. That is pi star. Okay, pi star enter అవుతుంది. So pi star లో one more electron. So pi star 2p y1 okay is equal to y లో z లో దేనికైనా మనం ఫిల్అప్ చేయొచ్చు 1 ఎలక్ట్రాన్ ఉంది. So can I rub this? So what is the bond order for it? So bonding electrons 2 to 4 sorry 2 already 10 is there. Okay, what is the anti-bonding molecule electrons? 5 2 okay, it's a 2.5. So 15 means here we are getting 2.5 means it is not the answer. Okay, next check for 17 electrons. Okay, so for 17 electrons, for this purpose we are doing 17 electrons means more than 15 కాబట్టి same sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 only here only difference is there. So you need to write again 17 electrons కాబట్టి more than 14 formula రాయాలి. That is sigma 2px2 pi 2py is equal to pi 2pz. Total 17 got 2 to 4 5 6 7 8 9 10 11 12 13 14. Fourteen, 15, 16, 17. Okay, what will be the bond order for 17 electrons? What is the bonding electrons? Bonding electrons how many? 2 to 4 without stars. 4, 5, 6, 7, 8, 9, 10. So minus 2, 0, 4, 5, 6, 7. This is 1.5. So it is having 3 bond order. It is 1.5. So they are also not having same bond order. So both are having bond orders 3, 3. Means what is the correct answer? Correct answer is O2 plus and N2. The fourth option is correct one. Okay, means we need to check the with help of configuration. Actually, so same type of more than 14 so the exactly 14 లేకపోతే above 14 అట్లా ఉంటే మనం కంపేర్ చేయొచ్చు. టోటల్ కాన్ఫిగరేషన్ రాయాల్సిన అవసరం లేదు. బట్ సో ఇచ్చిన 2 పేర్స్లో ఒకటి 14 ఉంది, ఒకటి అబౌవ్ 14 ఉంది. సో అటువంటిప్పుడు బోత్ ఆర్ కాన్ఫిగరేషన్ డిఫరెంట్ ఉంటాయి కాబట్టి సో వీ నీడ్ టు చెక్ విత్ హెల్ప్ ఆఫ్ కాన్ఫిగరేషన్. సో బోత్ ఆర్ బిలాంగ్స్ టు మోర్ దెన్ 14 ఆర్ లెస్ దెన్ 14 ఆర్ ఈక్వల్ 14 అయితే మనం సో డైరెక్ట్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఈక్వల్ ఉంటే కాన్ఫిగరేషన్ సేమ్ కాబట్టి బాండ్ ఆర్డర్ ఈక్వల్గా డైరెక్ట్గా రాసేయచ్చు. ఓకే, నౌ ద ఆప్షన్ ఈస్ దిస్ ఈస్ ద కరెక్ట్ వన్. You need to do this total rough work also. That is important. Let's see one more question. Bond order paramagnetic. So which of the following species has lowest ionization potential? Ionization potential, or is also called ionization enthalpy, simply I. Okay, so here the options are given: O2 minus 2, O2, O2 minus, see it is given so all are same and so we need to check that. So with the help of configuration we know that what is meaning of ionization enthalpy. In periodic table already you know that what is ionization enthalpy. The ionization enthalpy is the minimum amount of energy the minimum amount of energy required to remove an electron, to remove an outermost electron from a gaseous atom, is called its ionization enthalpy. Okay, so whatever it first or second electron, whatever it is, if second ionization enthalpy means we need to remove the electron from ion, means totally ionization enthalpy means the energy required to remove the electron. So electron remove avadanaiki మనం యూజ్ చేయాల్సిన minimum energy ionization enthalpy అంటాం. Now the question is, which of the following species has the lowest ionization enthalpy? So this is compulsory. By writing the molecular orbital configuration only we can do it. So we write the configuration for O2 minus 2. O2 minus 2 means how many electrons? 16, 17, 18 electrons. So what is the 18 electrons? Sigma 1 is, sigma star 1 is, y. 3, 4, 5, 6, 7. I have to write again. Now fill that electrons. So 13, 14, 15, 16, 17, 18. So all are paired electrons. We need to compare. Directly we can't say it's how much it is having energy. Just we need to compare the configurations. O2 means just 16 electrons. So 16 electrons low. So I am not writing the total configuration again. This it is also above 14 kabatti. So it is 1s2. It is common 1, 2, 3, 4, 5, 6, 7, 8. So the last will be changed. So at last it will get pi star 2py, so pi star 2pz. 16 carbon, it is 1 comma 1. So actually the 16 7. Okay, it's okay, it's total 18. 16 17 18. Here how many? It is only having 16 electrons. Okay, only 2 electron difference here. Okay, 14 up to here 16 completed. This is 17, this is 18. Here 2 filled electrons, here 2 unpaired electrons are present. Means why you are comparing the configurations means so to remove the unpaired electron easily compared to the paired electron. ఇక్కడ ఎలక్ట్రాన్ రిమూవ్ చేయాలంటే పేర్ ఆఫ్ ఎలక్ట్రాన్స్ నుంచి ఎలక్ట్రాన్ రిమూవ్ చేయాలి, విచ్ ఈస్ సమ్వాట్ needs more energy compared to the removal of unpaired electron. సో ఇక్కడ unpaired electron కాబట్టి సో ఇక్కడతో కంపేర్ చేస్తే here the removal of electron is easy. Okay, means so ఈ రెండింటి కంపారిజన్ లో ఇప్పుడు O2 minus 2 O2 లో which is having the lowest ionization enthalpy means this is low ionization enthalpy. But one more thing is here, we need to check the third option also. O2 minus means so O2 8 plus 8 power minus means it is 17 electrons. 17 electrons configuration. What will, so all for above 14 కాబట్టి I am not writing separately. It is pi star 2py is equals pi star 2pz. So ఇక్కడ వరకు మనకి how many complete? 14 completed. 15 16 17. So it is like this. So it is also having one unpaired electron. Now just can you guess which is required, which required less energy? So here just left it. Din manam din choice le, because here pair up of electrons, paired electrons unnayi kabatti it takes high energy to remove the electron. Left the first option. Now this compare the second and third option, BC options. Here 2 unpaired electrons are present. Here 1 unpaired electron, 1 pair of electron is present. So which is looking more stable? So which is looking more symmetrically generally stable? Here it is half filled, it is half filled. Okay, both are half filled. Okay, but the symmetry is present. Here this is, that is unsymmetry means both are not equal. Both are not equal but it is somewhat unstable. It is somewhat looking unstable kabatti the ionization enthalpy of O2 minus is least. Okay, So the answer is C. So means we can write ionization enthalpy order put right. What is ionization enthalpy order? O2 minus T, the highest one, as it contains pair of electrons. Next it is having a symmetrical. Next it is having only one unpaired electron. So that is easy for the removal. Okay. Next, see some more questions. So writing of this configuration is very important to solve many problems. Let's see one more question. So there is some very easy questions are there, so direct questions. So I am not giving that questions again. Next, one more question. Among the following, degenerate orbitals are. So see the options. Sigma 1 is, sigma star 1 is, sigma 2py, sigma 2px, sigma star 2px. Pi 2py, pi 2pz. So pi star 2py, so pi star 2pz. So which are degenerate group? Which option contains degenerate orbitals? First you need to know what is meant by degenerate orbitals. So what are degenerate? Normal atomic orbitals would rastam manam. For example, p orbital is 3 generate. Okay, 3-fold degenerate antam. P orbital is 3-fold degenerate antam. 3-fold degenerate. And actually it has 3 boxes. దీంట్లో 3 orbitals ఉంటాయి. px, py, pz. All are having same energy. అట్లే సేమ్ డీని ఏమంటాం? డీని మనం 5-fold degenerate అంటాం. So 5-fold degenerate means it is having the 5 orbitals. One orbital and 1 box. Say if the f orbital is having, we told 7-fold degenerate. 7-fold degenerate means 7-fold degenerate means it is having 7 boxes. Means I think now you got 1, 2, 3, 4, 5, 6, 7. Now you got what is the meaning of degenerate? Degenerate means same energy orbitals are called degenerate orbitals. Simply which are having degenerate pi 2py, pi 2pz. So both are 5, both are pi. So it is also. Next pi star, both are equal energy. In the configuration we used the word, we used the symbol equal because they are having same energy. Same energy orbitals are treated as degenerate orbitals. Okay. So it is helpful to write the definition that orbitals which are having same energy are treated as degenerate orbitals. Okay, next see the next question. See the next question. So find the number of antibody molecular orbitals. Antibody molecular electrons in O2. Okay, antibody molecular electrons. So it is a number. So direct finding number we solve this. So what is the O2 molecule means? O2 16 electrons, 6 write the configuration. Sigma 1s, sigma star 1s, 2s, sigma star 2s. So above 14 configuration aluminum. I think it is sufficient. Let us fill that electrons. 2, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Therefore, what is the anti-bonding molecular orbitals? Okay. So, anti-bonding molecular electrons. Well, here 2, 2, 4, 5, 6. Okay, total to the enclosure, next to the enclosure, here 1 total how many electrons? There is 6 electrons. Okay, what is bonding molecular orbital electrons? So they include 2, here 2, here 2, 2, 2. The totally 10 electrons. Okay, means the questions is also like this. What is the number of bonding electrons, anti-bonding molecular electrons? Okay, just we need to get the configuration correctly. Means number of electrons, the answer is 6 electrons. Next see one more question. Bond order is maximum among the following. So here the first option is N2, B, O2. Actually for bond order we need to get the total configuration separate formula, but as we did many examples, we know the it is having bond order 3, it is having bond order 2. Helium, we know there is bond order is not present, okay, because it does not exist. In the H2 we know that it's, so what is the which is having maximum bond order? N2. So if you don't know, if you don't remember, if you are unable to remember that number, you need to write the total configuration and follow the bond order formula. Next, one more important. So, which of the following species is which of the following is not diamagnetic? Okay, tomorrow or day after tomorrow I will send you a worksheet on this molecular orbital theory. Okay, so there is a couple of options are given. Okay, so which of the following is not sorry, that's not correct. So the options are wrong one. Which of the following is not a diamagnetic? That is N2, F2, Li2, DO2. So it is about magnetic characters. So already we know the configurations, we know the magnetic character. So already we know that the character of O2 is a paramagnetic character. So directly we can do this because already we done O2 example. But there may be more options. N2 you got the diamagnetic already. So if you want to get it is we have to do the more magnetic character the direct గా గుర్తుంటే రాయాలి లేకపోతే కాన్ఫిగరేషన్ రాయాల్సిందే. N2 14 electrons, sigma 1s, sigma star 1s, 2s, sigma star 2s, below 14 electrons. Okay, so sufficient for 14 electrons. Now fill the electron 14, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No unpaired electrons. So N2 is dia. If you remember, there is then you can do directly. Okay. So F2. What is the number of electrons? F2 means 9 plus 9. That is total 18 electrons. Okay, 18 electrons means what is the configuration again? Above 14 electrons configuration means first sigma to px, next pi to py is equal to pi to pz, pi star to py, pi star to pz. So here 18 electron 2 to 4, 5, 6, 7, 8, 9, 10, 13, 14. Okay, 15, 16, 17, 18. Even it is also having no unpaired electrons, so it is also diamagnetic. Then see lithium plus 2. Okay, let's do lithium plus 2. Lithium plus 2 means how many electrons? Can you write the configuration? Simply 6 electrons. 6 electron, no doubt. So sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, 6 are completed. So 6, there is no unpaired electrons, it is also so remaining O2. O2 means how many electrons? 16 electrons. With the help of this configuration you can write O2. Okay, so O2, if you have any doubts you can write again. So it's a guarantee that O2 will get para because 16 electrons means so 18 electrons మనకి ఇక్కడ 18 ఇక్కడ 17 18 so 16 అంటే 2 electrons పోతే ఇక్కడ 1 cancel అయితే ఇది having 2 unpaired electrons. So answer compulsory O2. sigma star 1s2, sigma 2s2. Pi 2p z2. So pi star 2p y1, pi star 2p z1, 2 unpaired electrons వస్తాయి. So కాబట్టి it is a para. Okay, so it is asked that which is not dia. Not, all three are dia, so it is not the dia. Okay, so today I will send, tomorrow I will send the questions. Okay, just only 10 questions on this theory.